Okay, there we go. Get the screen recording on. So when we're talking about something, function is usually what we're talking about. We use a lot of things like domain and range. Which one means what? Do you remember? Domain stands for what? Remember? It's been a hot minute. Okay, if we don't. Domain is our x values. So domain is the, let's see, I'm going to switch that to the feather pen. It's our x values. Also called the input. It's what I am putting into the equation to get some output. Sorry, my handwriting will get better as we go through the day, but right now it kind of looks like a third grader wrote it. So the domain is what we put into the equation. So I pick an x, I plug it in, I type it in, and it spits me out a value. It spits me out a y value. So the domain is our x values or our input, which means our range is our y values. It's the first time I've written on this iPad in like 2 months, so it's going to take me a minute to get my handwriting resettled. Or my output. So we type in our input values, and it spits us out an output value. Those we should have heard before. Domain and range we should have heard before. It may have been a minute, but we've heard them before. A function means each input has only one output. Each x leads to only one y. Each input gives only one output. Meaning, if I type in the number 2, I'm only going to get 7. It's never going to be that 2 gives me 4 or 7. Each input gives us only one output. That is honestly most things we've dealt with up until now. Like lines, parabolas even. The way we test if something is a function is called the vertical line test. If we have a picture, if we have a graph, we do the vertical line test. Which means I need my super duper high-tech, fancy schmancy vertical line test tool, also known as a steek. Vertical line test is literally we take a vertical line and we say, does it ever cross more than once? You use a steek of power. And I will show you what this means when we get into some pictures. So functions are honestly going to be what we deal with most of the time. Most of the things we deal with are going to be functions. A one-to-one is a special kind of function, meaning it has to be a function first. So it has to have that each input gives only one output. And, so it is a function. And each output gives only one input. So I'm only going to have one y value of 2. I'm only going to have one x value of 4. I'm never going to have any duplicates on anything. And this one also has a special test when we're looking at pictures called the horizontal line test. horizontal line test. Bless you. I'm gonna give you guys enough time to get this all written down. All right, questions on this so far? Because we're going to look at some pictures. And we're going to use a few different ways to write about these pictures. You do not need to have this specific graph. Hello, my dear. Thank you. At this point, we do not need to have the specific graph. I can get you the specific graph because I got it. So I have the graphs here that we're going to look at so that you don't have to sketch them in. You can sketch them in. You do not need them to be super specific, but I have them in case you're one of those people that likes to have them, exact. So I'm going to put some of the graphs and some scissors and glue on each set of tables. Each row is one set of graphs for today. So if you are a person that likes to have them exactly right, I got you. If you are okay with the sketch in your notebook, that's fine too. I'll get the scissors in a minute. So just one row is all you need. I just got extras here to be put something You're going to be using these graphs today and tomorrow probably. So you should just need to cut up between the three graphs and glue those in. You'll just need a little space next to each one of the pictures. Because we're going to talk about the domain and range specifically for these images. We're going to find the domain. We're going to figure out what the heck that is. We're going to figure out if it's a function, and we're going to figure out if it's a one-to-one function. Okay, so on this first one, I'll do the whole thing myself, just so we can see what the heck is going on here. So, on this picture, this U-shaped graph, what we're looking for in the domain is what x values work. Oops. So what x values work. That's what the domain is, what x values there are. Well, I know for sure, -2 works, -1 works, because I could pick this x and I could find my line. It's kind of true of everywhere. My x value at -2 would give me this part. I could pick -1 and get this spot. I could pick -1/2 and get this spot. I could pick 0 and get this spot. I can pick whatever spots I want along this line and find a valid answer. I don't care what the answer is, just is there an answer? Yeah. The ends of these, because of the graph program I use doesn't like to put arrows on it, didn't have arrows, but it should. So this continues out and up forever and ever and ever and ever and ever and ever and ever. Meaning I could use any x value in the entire existence of the known universe and do that. I could pick negative 500,000. I could pick positive 1.8. I could pick pi. I could pick 437,852.4. I could do it. It would not be nice, but I could do it. So I could use any number in the entire existence. What we do is we call that all real numbers. Which, if you just want to write out the words all real numbers, that's totally fine. There is a lazy person way to write this. And what that is that is an R with an extra stick on the back. I'll do that again, just so we can see it. It is a capital R with an extra vertical piece. That is terrible placement. I tend to put mine inside. Putting it out the back isn't wrong. So that is the easiest possible way to say all real numbers. The set builder notation, we're going to use that a little bit. All that means is we're going to take kind of our algebraic notation and put it in squiggly brackets like this. It'll have more specific rules we talk about in a minute. And all that means is there is a set of all real numbers. The most common one we're going to use is going to be our interval notation. And these ones get a little picky sometimes. So it's going to have parentheses and brackets is what it is. And what this says is we're going to have from my smallest number. The smallest this could ever be is as small as I could possibly imagine. So the tiniest infinity you can think of, negative infinity, all the way up to positive infinity. Those are 3 different ways of writing the exact same thing. Those all mean the same thing. We are definitely going to be using algebraic notation and interval notation the most, but the squiggly bracket you could see in your books, and I don't want it to scare you when you go, what the heck does that mean? It just means they're lumping it together and they like to use fancy brackets because mathematicians extra. Super extra. They all mean the exact same darn thing. So I could use any x value in the entire existence of the universe. That is what our domain is what numbers could I pick? I could pick whatever I wanted. There is no wrong choice to pick. My range, what that is that's looking at where do those x values spit us out? What are the y values? So what y values do we get? So when I picked my x of -3, we got 4. When I picked my x of -2, we got 0. When I picked my x of -1, we got -2. X of 0 gives us -3. Anyone notice a pattern with my y's there? Is it going to be all real numbers again? No. You're right. Good guess. Because is there ever any x in the entire existence of the universe is going to land me on -4? Does my line touch there? No. What's the very, very smallest my line can be? negative 3. Ooh, hang on, I gotta zoom my picture back in. So my y values are going to be greater than or equal to negative 3. That's our, yes, sir.
But if the line's going like that, can it also be negative 1, the x value?
My x value could be negative 1. My y value could be negative 1. So, because when my x is negative 1, my y is negative 2. When my y is negative 1, it's over here. Did that help? Okay, cool. It's like if I ever answer your question, it winds up not answering your question because I didn't understand it. That's totally a me thing. Feel free to re-clarify. So the very, very smallest this can be is negative 3. I can't, there is no point in the entire existence of the universe that'll get me down to negative 4. So when this goes into the set builder notation, what you'll see if you look in your book, they use the squiggly bracket. They say, all right, y exists such that y is greater than or equal to negative 3. It's just silly extra stuff. I'm never going to ask you to write it in the set notation. Like, for realsies, algebraic and interval are fine. I just don't want you to look at it when we come to things later in the year. They start writing stuff in set builder notation a whole lot, and it's really annoying. And I don't want it to scare you. All it is the algebraic notation with Christmas lights around it. It's the same dang thing. Okay? So set builder notation is not a huge deal breaker for me, but I need us to be able to not panic when we see it. Okay? It's the only reason we're going through it. Interval notation is a bigger deal. We'll use that one a lot. I will write it a lot, and it's important that we know what's going on here. So we list our interval from smallest to biggest. So the smallest my y values can be are negative 3. And they go up to infinity, right? The highest it can go, I can go as high as I can possibly imagine. This is going to use two different brackets. Up here we use parentheses on both of them. This one we use parentheses on the infinity. But we use a square bracket on the negative 3 because of this equal sign. The square bracket means I can touch it. I can come up here and I can say negative 3 right there, and I can put my finger on it. I can touch it. And it gets really grumpy if I actually touch it. But I can touch negative 3. It's right here. Poke. I got it. I can't touch infinity. It's not a thing. I can't put my finger on it and say, here is infinity. Haha, I'm in. You can't do that. Infinity is an idea. It's a concept. It's as big as we can possibly manage. Imagine. That's the word I was going for there. Y'all, I am falling apart this morning. Okay, so negative 3, we can touch it. It can equal it, so we use a square bracket. The infinity is an idea, we cannot touch it. Or if we have something that was ever like a less than, not equal to, we would use the parentheses. So if we can touch it, we use the square. If we cannot touch it, we use the curved. Questions on that whole lot of information I just threw at you on our domain and range? And now we're going to do our function test with our high-tech, fancy schmancy steek. You can use a pencil, you can use a ruler, you can use your finger, it don't matter. Stick of power. To test if it is a function, we do a vertical line test, meaning I hold my stick vertical, and we run it across my picture from left to right and see, does it ever cross my line more than one time at the same point? So is it ever crossing more than once? No. So this one is a function. That is the extent of the vertical line test. So it passes vertical line test. So it's a function. I will often abbreviate that to VLT because I am lazy. To test that one-to-one function, remember it has to be a function first, so it is a function. So then we go horizontal line test. Make our stick sideways. And we see, does it ever cross more than one point at a time? Yeah, it's doing it right there. And there, and there, and there, and there. There's only one place where it doesn't, and it's right on the tip right there. So if it ever fails, ever any singular instance, then it is not a one-to-one function. So this fails the horizontal line test. So it's not one-to-one, which I will not put it like that. So it is a function, but it is not a one-to-one function. My domain is all real numbers, and my range is y has to be greater than -3. Yes, sir.
Do we have to put passes or fails? Can we just put yes or no?
I am totally fine with yes or no as long as you know why. If I ask you a why question, you can just put passes, HLT, passes, VLT. But yeah, it's your notes or your notes to write whatever the heck you want. Okay. Those are all of the things we are doing on this first graph today. Questions on any of this that we see? Okay. Because if you couldn't tell by the fact that you had 3 graphs, we gonna do it again. So you got another graph? We looking at this same graph? We gonna do the same dang thing. And again, it's supposed to have arrows on the end, but my graphing program is a grumpy Gus. So we just draw them in and pretend that they're there. So there's something weird on this graph. It kind of looks, yes, my friend. Okay, yeah, move where you need to be. If you ever need to change these to see better, totally fine. I literally take my seating chart and I put Post-it glue behind all of your pictures, and I will just pick up the Post-it note and move it. Because I don't care, I just need help remembering your names. Okay, so there's something weird on this picture. There's this weird little circle thing. This, which you will get into near the end of this year, not semester year, that's called a hole. Quite literally, think of it as somebody took a pen and stabbed a hole in the line. As just a little dot where it does not happen. That is a hole, is what that's called. So everything else is true. It's just somebody took my line and they just like cut it right there. Or stabbed a little hole in it. That's all that little circle means, is it's a hole. Okay. So we're going to look at our domain on this one. What x values work? Does -2 work? If somebody stabbed my line and poked a hole in it, or took a hole puncher and took a little chunk out of it. Yeah. So -2 doesn't work, but how about anything else? What does work? 2 works? 0. What else works? 1 works. -1 works. 3 works. 4 works. 5 works. Something a pattern? It is actually almost anything in existence in the universe. Except what? -2. I could use anything in the world except -2. So what I'm going to say is I'm going to say, ooh, that's like super skinny. We're going to switch that to this pen. X cannot equal, and you just do an equal sign with a line through it, -2. And I'm cool with that. That is perfectly acceptable for everything. Everything except when x is -2. And set builder notation just does the same thing. X is in the real numbers except when x not equal to. Like, they're silly long, these set builder ones. They're redonkulous. It has all the same information. It's just being like super duper extra clear that x is in the real numbers and it don't equal to. -2. Gosh, sorry, I forgot the negative sign there. Also, if you ever see me write something wrong on the screen, please, please, please feel free to tell me. I spell stuff wrong all the dang time, and I make mistakes because I'm a human. Again, I am more interested, as long as we can come up with this rule, this notation, don't bother me. It's just so that we don't freak out if we ever see it in that notation in the book somewhere else, okay? Our interval notation is extra because we need our pieces that work. So I can have my -infinity, which is the smallest my domain can be. The biggest this piece of the domain can be is -2. It stops there. And then we have another piece of graph where it starts at -2 and goes to +infinity. Yes,
Why doesn't -2 have the bracket?
excellent question. The -2 doesn't have the bracket because if I touch -2, it's not valid on my line. It's that little hole on it. Excellent question. Because, yeah, it's a number that exists. I can poke it, but it's not valid on my line. If I typed -2 and I had an equation in the calculator, it would give me an error because it doesn't work. Thus why hole was punched. And we will get into what punches holes like that in February, I think. So you'll be able to do these by the end of the year. Make this graph. End of the year, you'll make these. Yeah. And you'll know what they mean and what all those pieces are. So it's kind of cool. You'll get to make this by the end of the year. All right. So then we're going to do our range. What do we see about our range? What y values do we get? 5 works. 4 works. 3 works. 2 works. 1 works. Does 0 work? Do we have any time that we'll get a value of 0 as my y? Let's say I'll use my stick. Does it ever have a valid answer there? Really? Yeah. I have 2 other options for an answer at 0. So is there ever a y value that doesn't work? Or can I get an answer absolutely anywhere I could think of?
Yeah.
Anything. I can get anything. So what this is that our range is all real numbers. Oh, I gotta zoom that in. My handwriting is so much worse when it's zoomed out. So it's all real numbers. which you can, again, write out the long way, or funky R. R with two sticks. And again, Set Builder just uses the fancy squiggles. And it says there's a Y that exists in real numbers. Since we can use absolutely any number in the existence of the universe, that's when we're doing negative infinity to positive infinity. Just like that. If your algebraic notation is all real numbers, your interval notation will be negative infinity to positive infinity. Those two things are the same. They mean the same thing. This is algebraic. This is interval. They mean the exact same thing. So if you get this, you can hop right down here and write this. It means the same thing. And again, these are the two pieces that we're really going to work with most frequently. Set Builder, I just don't want you to get freaked out when they look crazy. But these are the two things we work with most. It is so hot in here. Holy cow. All right, so we're going to do function and one-to-one test. Function. Stick of power. Which always makes me want to do the stick on the ground and I want to use it. The old TikTok song or TikTok sound. Okay, so slide it along my graph. Does it ever cross more than one time? Nope. So it's a function. Bink. It passes our vertical line test. Is it a one-to-one function? No. This whole chunky here in the middle fails our one-to-one function. It's like it works on either end, but if it ever fails, it fails. So it is not, oops, let me switch to pink, not a one-to-one function. Question on that one. I'm gonna update these today. Okay. One more that we're gonna look at. I think we're starting to get the hang of it. And it looks a little cray. It's just dots. This is the only time when Set Builder notation is actually freaking helpful. It's just a list of separate dots. So all we do for something like this, where it's just a line of dots, is we straight up list our values. So remember that our domain, these are our x values. And all we do, I'm just going to write this in my Set Builder notation spot right here. We do the squiggly bracket, and we straight up, left to right, write the values. My x values here, -3, -2, -1, 0. Like just straight up list them out. 1. This one we have to estimate, it's about 1.5. And 2. I know I'm in my lines there. Algebraic notation is exactly the same list, just without the squiggly brackets. It's that x equals -3 or -2 or -1, 0, 1, 1.5. So it's like straight up a list. And there's not a way to write this in interval notation. Because there's no intervals here. There's nothing connecting it. Interval notation is all about the lines that we draw. And there's no lines here. So we just straight up make a list. And if for our x values we straight up make a list, when we look at our range, and we look at our y values, that looks like a weird 4, but what else? It's a y. We're gonna do the same thing. We're just gonna make a list. I put my squiggly brackets. And we're making a list of our y values, smallest to biggest, which means I'm gonna start at the bottom and work my way up. So we've got -1, probably about -1/2. I don't know, I'm guessing. We're estimating here. This one is on 0, 1, about 1.5. That is a terrible 2. Holy cow. There we go. And then we've got this guy that's up here at around 3. And this guy that's here around 4. This is the only time that subbuilder notation is easiest of all, because you just put it in the squiggly brackets. Because algebraic notation, I'm going to just say y is, that's an s, there we go, -1 or -1/2 or, like, and you just list it out. 0 or, and it's just really long. And again, the interval notation does not work because there's no interval. There's no line in between dots. Two last tests, which are totally valid and we could still do even though it's just covered in dots. Which I'm going to erase all my little bitty dots so that we can look at it and see. And then we're done. I promise. We're super close to the end. So looking at our little dots, we can still do our vertical line test, our function test. Is this a function? Do I ever cross more than one dot at a time? Nope, so it passes the function test. Huzzah! It's a function. Since it's a function, we can do our one-to-one function test. Does it ever cross more than one dot at a time? No. So this one is a one-to-one function. That's our only one that we have today that was a one-to-one function. And I know these pictures are kind of obnoxiously weird. They're the actual ones from inside your workbook. These are the ones that you put in the workbook. Which is why you ranked them. That would be the reminder for the video announcements. I will very rarely go all the way up to that bell, especially once we start getting video announcements, because I try not to bell to bell you. But this is one of those ones that takes a ton of vocabulary, and they're kind of weird to get used to. But I do my best to try to give you at least 5 minutes before the announcement bell. Just didn't happen today. So, homework 1.1, it's those numbers in the book. I do also have it that we'll print out on a worksheet.
Good morning, Red Devils, and happy Monday. This is Principal Wallace. As we start another great week here at Pike High School, I wanted to give a few updates.